Now, in related rates, we will have unknowns variables which will be connected to each other, but their rates won't be with respect to each other, but with respect to different variable, which is time. So will be mainly when one is when one has a one rate, what will be the rate of the other one. Okay, let's see in a problem. It will be more clear, I guess. So what do we need to do to be able to solve such problems? You need to draw a diagram to see the picture, and then you need to relate them, relate the variables, so which the rules you can need, the Pythagoras, the similar triangles, the cosine rules, sine rules, simple trigonometric ratios, whatever you can find, the area formulas, when you can connect two variables. Okay, then in the step 4, you need to use the differentiation chain rule, mainly with respect to time, the third variable, and then based on the your question, whatever they ask, you need to answer the problem. So let's see in a basic question from your book, number 2. We have a square, it has a length x and the area a. The side length of the square is increasing at the 2 centimeters per second. So if side increases at 2 centimeters per second, what will be, I guess, that then yes, they are asking you how the area will be increasing, what will be the speed of the increasing of the area. So let's first, of course, simple one we need to do. Okay, we have the diagram. Let's relate these two variables. It's very easy. So how we can relate them? It's actually a equals to x squared, right? Area and the x squared. Now differentiate this part a with respect to time. So we have to use chain rule. Our idea is, if they were asking dA dx, what we will do is just simple 2x. But they want with respect to time. With respect to time is dA dt. So it will be dA dt, sorry, dx. How was the chain rule? Times dx by dt. This one is chain rule. So let's do each of them separately. So the first one, dA dx, we know that it's 2x. The first one, and the second one, dx dt, we don't know. Okay, so it will be like this. So let me rewrite it one more time. dA dt equals to 2 times x dx dt. Now let's try to answer question number C. It says, at what rate is the area increasing? The area is increasing when the side length is 6 centimeters. So what do we need to do? Instead of x, I'll put this 6. And from the beginning, they already tell me that the side is increasing with 2 centimeters per second. So this speed, let's call it speed, 2 centimeters per second will be times 2. So area is actually increasing at 24 centimeters squared per second. So it's the speed of the area, how it's increasing. Let's see one more question. Here again, diagram is given. So in some question it will be given. I chose the easy ones. Also, you can check the problems from your book. Number 11. Okay, we have the triangle PQR. Tan is given, angle is given. If PQR is increasing at 2 degrees per minute, so our angle is actually has a speed. It's increasing 2 degrees per minute. Okay, let's mainly simplify like that, 2 degrees per minute. As PQR increases, would you expect the QR to increase or decrease? So as this one is increasing, what they're asking, QR. Will QR will increase or not? So if you just try to draw it, if we just extend it, if angle is increasing, the QR will also increase, and also PR, right? As angle increasing, QR will increase. So the first one, they're asking whether it's increase or decrease. At what rate is QR is changing when PQR measures 60 degrees? Okay, now what do we need to do? They are asking the angle and QR, the relationship. Can I relate QR? Let me call it, let's call it X, this side QR. And let's relate this angle with respect to givens. So I have 10. I have x and I have angle. I need to relate them. How I can make a relation? How I can connect them? By using trigonometric ratios, as it's 90 degree. So it will be cosine of the angle equals to cosine 10 by x. So if I rewrite it, should I rewrite it? So it can be they're asking t. Okay, let me rewrite it. It will be x divided 10 by cosine of angle. Now, if I want to find the rate of change of x, so what I can do, if I rewrite it one more time, just I want to make it simple, 10 times cosine theta to the power -1. Now, here it's good. Because otherwise you need to use the quotient rule, it will be very long. Here is the simple one. We'll do just a simple differentiation. Now, if you find the differentiation of now this side, it will be dx dt, and 10 times we need to use chain rule, so it became kind of -1 cosine theta to the power -2 times the differential of the inside minus sine theta. Now times dt by dt d theta by dt. Now we need to input the values now. So what will be minus sine -1 will be positive 10 times sine of 60 degrees divided by cosine square of the 60 degrees. And here I almost forgot, this part must be always in radians, don't forget. So it's given in 2 degrees. How do we can convert to the radians? Just multiply by 2 times pi by 180. So if we calculate this one, what will give us sine 60 root 3 by 2, 5 root 3 divided by it will be 1 by 2, 1 by 4, 8 pi divided by 180. So if we need to calculate this one, calculator, it gives the result 1.21 centimeters per minute.